In the second half, which is going to be presented by Sven Fillinger, you get a more deeper insight into the implementation of FAIR. And Sven is coming from a different direction. He did a master's in plant molecular biology, so a wet lab scientist by training, University of Hohenheim, and then continued to do or be a PhD candidate at the Center for Plant Molecular Biology in Tübingen. But since his heart is beating for bioinformatics, he switched gears and did a master's in biomathematics and bioinformatics and computational biology at the University of Tübingen, and is now the team leader of IT and software development at the Quantitative Center, Biology Center in Tübingen.
Thank you for the opportunity. I'm really grateful to have been invited here to talk about a more implementing perspective of FAIR, since this is a topic challenging QBIC as well, and I think it has a lot of people are interested how to actually translate the principle and guidelines into implementation. It was also challenging for me to fill up all what I wanted to talk about in 20 minutes, and I am sure that I cannot, so please apologize if I cannot go into depth for the various topics, but I try my best to touch some of the points and give you some directions how implementation could work. So when we talk about FAIR, metadata, the term occurs very often, and you might get the impression that FAIR is all about metadata, and when you care about metadata, you are FAIR. And metadata is indeed a central and core part of the FAIR principle. However, it is not everything, and there are some technical perspectives and measures you need to take to implement a FAIR aligned framework. And some of these points I want to touch today. I cannot go into too much detail, but we will see how some of these technical measures can help to make data especially findable and interoperable. So I promised to talk a little bit about the myth of the right model, and that has to do about especially if you build a software architecture on top of models and the problems that lie on it. And here I want to give some advice or some insights that we have gotten over the last years when working with metadata models. So first of all, when we talk about metadata models, this is not the same as when you talk about a domain model. So, and we talk about domain models, that is something that you include in your business and when you relate entities, but also decorate them with business rules and certain behavior and events. And this is something what you usually don't do with metadata models. So I want to give a warning here. If you build all your business, so as you are a data center, for example, and you build everything on your metadata model, and this is your foundation, this can get very painful at a certain point, especially when you change the metadata model in the core. Everything will be affected, and you can get can reach points where you have really hard time to adjust your business. And we have done that at QBIC, and we have seen that it becomes very problematic. So be aware of that. This might not be the same thing, and you might not do that and still comply to the FAIR principles. So and what the second thing you should really try to avoid is, if you have an internal model in your organization, you should never ever expose it to your clients or other machines that consume your data, because once you created this dependency, that means you can never change anything in your business model without affecting any of your clients. So from a software perspective, some measures you can do to protect everyone consuming your models, and you can freely change what you do internally in your organization without affecting them. And I want to give you some directions, what, if you're interested in that, what you should look up. Some of you might know the term of domain-driven design that is exactly tackling this problem. And two of the most prominent members are Eric Evans and Vaughan Vernon, that have written some very interesting, and I highly recommend to read the books if you're interested in it. And I hope that the slides are also shared, so you can look up the ISBN numbers again. If not, domain-driven design, you might recognize the covers pretty easily. Maybe you start with the middle one because it's a very lightweight written and short version of the other both. How domain-driven design in your organization should work and how to build the right models. And then you can go dig more into deep. And no illusion, this is a hard topic to master and it takes probably years to do that, but we learned that this is, it's worth it. So when we talk about models in FAIR, usually what we are talking about is semantic models. And what we usually want to achieve here, this is something that we expose, for example, at Cubic as a data center, we expose something to the outside world, humans and machines, via an API to make it accessible and readable. And this is usually when we talk about metadata models in the context of FAIR, what it is about. And to pick you up into the topic in the deep dive, so when we talk about concepts and things in semantic models, I provided an example here and just talking about color and the properties the color here that can take. For example, color brown, green, and blue. And with just seeing that, you have no idea what I'm talking about, right? I mean, color can be mentioned in everything. So the first intuitive thing that you would need to do is to provide a context. So now with the context, human eye, it's much more clearer when I'm talking about color, what it is about. And this is something we do as humans intuitively. We determine the context when we listen to something, but for machines, that is really hard to do. So we need to take that into account. Once we have defined the context, we can do something really cool. We can form up relations between objects and create expressions and relations between them. For example, we can say an iris has a color, and so now we formed a first semantic model from the human eye. And many of you might already know this. If not, this is a common triplet that is formed here, and this is called subject, predicate, and object. And when you have this, you usually talk about an ontology. And this is one of the important building blocks of semantic models you want to have. And together with the context comes actually the power to describe something in your domain. Another thing that you now might want to do is not only building the semantics and give the context, but you might also relate different data sets or metadata description blocks with each other, either within an organization or even across organizations. And this is now something from a technical perspective that is a little bit challenging. So how do you do that to create this semantic web to actually that machines can navigate through and see what data sets are related to each other? And how can you do that? How can you link data sets in your organization with others and so on? And this is something that seems a little bit challenging, but I will show you that much of the technology is actually already there and has been there before the FAIR guidelines have been brought up. And I gave a very common example, and you have seen that probably every day when you Google something, but you might have not thought about it, so I brought it up here. So when you Google something with Google or with a Bing search engine, you get something, you get an overview, usually it's called knowledge panel, that's really customized to what you have searched for, and it gives you a very good overview of something that you are interested in. Here I took an example. I just yesterday Googled for Corona, and what you get is a really structured overview of information about Corona. It's not the classical tabular link list that you get. So this is really cool, and you might wondering how this is actually possible. And of course, the answer lies into structured data that is behind it. And the structured data that is then able to create a semantic web for machines to interpret into information and to build something that's more intuitive for your context. That is an idea that the inventor of the internet, Tim Berners-Lee, actually already formed in 2001 and had this vision. And I found this relation pretty cool, because this is something that we also want with fair data, right? So we don't want only humans to comprehend semantic documents, but also enable machines to do so. That's where the real power lies. And to that, I want to introduce how a semantic web and linked data can actually work with a lightweight framework, so that you achieve human and machine readable information using a schema and a certain notation standard. There are much more out there, but I picked out these two because I built up the storyline on top of that. So the schema I will talk about is schema.org, and the notation is JSON LD, which stands for linked data, and is built on the very well-known JSON notation standard. For simplicity, I took the example that you find also when you go on the JSON LD website. So you will see that this is exactly what I talked about in this presentation. And what you do usually is, in this notation in your source code on your web page, for example, is exactly what I have talked about the previous example with the eye. So first of all, you provide some context for the machine and tell the machine it's about a person that you're talking about. Then you build an identifier and some properties. And these are the central building blocks that build a fundamental basis for structured data that can form the semantic web. So you have a persistent and globally unique identifier, which is usually an internationalized resource identifier. Here in this case, it's an URL. You have some properties, here maybe a date type, and you have a link to another resource in the web, which is also an persistent identifier, ideally. So, and if you do that, you automatically provided a linked web between two dataset nodes, here in this case between John Lennon and his first wife, Cynthia Lennon. So this is already what it is about, to create a semantic web of linked data, and the machine will be able to talk about it, because you provide everything that would be need for it. But now you might say, okay, but what we are still missing is the schema, right? So without a schema, this won't work. And the good thing is that this has already been created by the big tech companies already years ago. This is the fundamental basis. They create structured data and bring you a very awesome user experience when you search for content in the internet. And I will show you how this looks like. On the website schema.org, you will find all the different types of common entities, and it's very lightweight. Everything is optional for the moment, and you can easily create this structured metadata with the schema.org semantics. When you look into schema.org, you will also find some highlighted things that look a little bit suspicious. So measurement technique, this looks like it comes from a scientific domain, right? And this is actually the case because something happened in the last years, and some community-derived properties has been taken over into schema.org. And this is also one of the reasons why I actually took the example I'm talking about now, because what I really like is that this community approach, is not trying to recreate yet another standard, but builds on an existing industry standard and decorates it to make it useful in the life science context. And I don't know how many of you already know it, but what I'm talking about is bioschemas. So bioschemas is an Accelerate funded project and part of the Elixir infrastructure, and super cool project, super nice people that are building on schema.org and trying to bring scientific types into the original schema.org definition. And bioschema.org is an extension on schema.org, and it has two building blocks. One is a profile and one is a type. And profiles are actually nothing else than types, but with a recommendation of what should be the minimum metadata that you should provide in order to give metadata description meaningful content, since in schema.org everything is optional. And they form some recommendations of what you should provide, and then there are some optional declarations. All of that you will find in profiles. But they also define new types and make suggestions to bring these types into schema.org. And this is already happening, like molecular entities, things like that are already on the way into the schema.org standard. And what you would now typically do, and this was one of the previous questions, and this is called a crosswalk. So what you would go through your internal model or your, let's call it, database, and you are doing a crosswalk and trying to map what you have to the bioschemas, types and properties. And of course, the central question is now, when you have done that, is it already enough to make it findable? And of course, it's not yet enough. So the question is still there. So how is it actually indexed, and how can it be found? The description alone is not yet enough. And some of you might already have tried it out or are aware of it, that Google introduced the Google dataset search in, I think, 2019, if I remember it correctly. And like Google Scholar, it's an own index that provides a very an overview and a search engine to search for data sets specifically. And you can do that. And I did it just yesterday for a data set that has been indexed, and you will end up in the European Genome-Phenome archive. So pretty interesting. So these guys already did a good job, obviously, and to providing some structured data to make their data sets findable. And you can all confirm that by yourself if you navigate to the GHGA website and open your browser and go into the website's source code. And if you scroll down, you will find a markup that looks like this. And this is exactly what I have shown you in the previous slides. So they provide the context, which is the schema.org context, of course. And they made use of a type that is called dataset. And if you go to schema.org, you will find it, all these properties. And so this is actually pretty cool that they did it, and you can all reproduce it, hopefully, after this presentation by yourself. And how this actually work is that Google makes use of their existing Googlebot crawling infrastructure and goes over websites, but it's not doing a full text indexing, what they usually do, but they go over the structured metadata only and make some cool normalization things and try to get out replicas and redundancies. I cannot go into detail yet, but I linked the original presentation publication if you're interested in it. And by the end of the day, you build an index of these reconciled metadata. And what you now do is basically you can just use the Google dataset search on this index to find, based on the structured data sets you might be interested in. The problem is, as always in a federated infrastructure, if you're new to this network and nobody knows you, so no machine in this case knows you, you're a little bit alone and on the side of this thing. And this is called the long tail problem, and can be problematic because your content that you provide on your webpage, for example, if you want to expose data sets in a fair manner, that you might not be found. And the good thing is that when we provide data sets, it's not so, they don't underlie frequent changes like a news website, for example. So once we provide a data set, it's enough if it's indexed once, and it's usually not necessary that it's indexed in a daily manner. So it's a little bit less dramatic for static pages. But however, the big search engines also come with quite a lot of recommendations what you can do to still make your website discoverable, and therefore what we want to aim for, findable. So point one, maintain your sitemaps. So for the ones of you who are familiar with it, the sitemap is the small file that you put on your website that gives the crawler possibility to access it and look to all the URLs that you provide on your web server, and then these get visited and indexed. So this is the first thing. So you should maintain this. We have seen actually when you don't maintain it, we have seen it in the biohackathon for the NFDI for Chem group for a big repository that provided structured data, where one of the properties were missing, meaningly the property of when the content changed the last time. And we have seen that for 3 years the content has not been re-indexed, although the Google bots were visiting the site a couple of days ago before the hackathon. And once this was updated, it's then landing up in the index, and it can also be found via the Google dataset search. So this is one thing you should be aware of. You can also actively request crawls, though you don't have a guarantee that the search engine will visit you, but this is still recommended. Google comes with a search console for that. And you should make sure as a web hoster to minimize your loading time. So these are some of the recommendations I just found these days from Google. And so I also want to briefly talk about persistent and globally unique identifiers, because I always see that people use DOI as a synonym for persistent and global identifiers, which is okay. A DOI is an implementation of a globally unique and persistent identifier, but it's only one possibility, and there are others. The DOI has the disadvantage that you are usually bound to the schema from the DOI authority, and that might not always suit you what you want to achieve. And so I want to give you the hint. I was not familiar with it, and I was happy that somebody told me that this exists. And this is identifiers.org, which is also part of the Elixir infrastructure. And this is an authority that resolves digital identifiers. And I'm pretty sure that this will be a sustainable infrastructure for the next decades. And this is really cool, personal opinion, because you can also customize the identifiers to make it also appealing to represent your organization. So for example, you could form something like GHGA colon and then your unique whatever dataset ID that you use internally, and provide this URL, for example, and this would be resolvable completely by a machine, and would be also fulfillment of a persistent and globally unique identifier. Pretty cool. If you want to do that and register your organization and your own identifier namespace, they ask you for a persistent identifier of your organization. I was like, when I did that, I was like, I don't know if Cubic has a persistent and unique identifier, and it had not, but the University of Tübingen had. The thing is, it's pretty straightforward to submit a request to get it. It's landing up in GitHub automatically, and it goes through some iterations to get evaluated, and if it passes, then they will create this entry for you. And I did it before Christmas, and I think 2 weeks ago or so, we got the confirmation that this entry is now here. And yeah, it's pretty cool. So Cubic has also a globally unique and persistent identifier that we can use in FAIR data sets, for example, to point to the organization. So, and if you have not done that yet, I happily invite you and point you to the ROR, the Research Organization Registry, to check if your organization is already registered there, and if not, do it right away. And yeah, that is it already from my Frog's perspective towards implementation.
Thank you, Sven. That was a really good intro into how to implement FAIR. I would give the word now to anyone who has a question. Don't see anything in the chat at the moment. Is there anyone out there who would like to unmute and ask a question? I maybe can start with one. So we heard a lot about the semantic web and its potential to do FAIR framework implementation, but maybe a naive question, can it be done without making use of the semantic web?
Yeah. I mean, the FAIR guidelines don't really, I mean, it's just a guideline. They don't tell you how to do it. Yeah, so it's up to you to come up with the implementation. There are some recommendations, of course. The point is why I hinted to the semantic web is that I think it makes totally sense to make use of this infrastructure that is already there, and this is the fundamental basis of how the internet works. So I'm usually trying to not reinvent the wheel, but look into solutions that are already proven that they work and join them and rebuild or extend what is already there. And this is what bioschema does. And when I did the research 2 years ago and found bioschemas, I was like super convinced. It's lightweight, it builds on existing standards. That's something that gets you going with pretty, I would say, not so much effort to an implementation that is FAIR compliant and actually works and is sustainable and can also be used by classical search engines. So the answer is technically yes, you would be able to do so. The question I would ask is, do we need to do it differently or build on how we probably should do it? Yeah.